On November 29th, ThreeI Atlast suddenly displayed behaviours that looked like a system designed to confront and actively interact with the Sun, triggering a wave of urgent questions across the scientific community. Atlas carried a tail leaning back toward the Sun, an unexpectedly low mass, a hollow metallic shell rich in nickel titanium, and a hexagonal lattice like a thermal armour, leading Avilo to place it at a very high level of extraterrestrial probability. After slipping behind the Sun and reappearing, Atlast returned brighter, held a remarkably stable temperature, emitted ultraviolet pulses in prime number sequences, answered with mirror signals encoded in fractal structures, built on the golden ratio, and used a subtle thrust plume to adjust its trajectory, as if self-steering and completing an observational mission. In parallel, Voyager 1 was reoriented into an interstellar observer, receiving self-correcting signals linked to Atlast, gradually rotating to align with Atlast's future path. The golden record revealed a hidden prime rhythm. The data stream appeared to upgrade into an active watcher layer, and eventually Atlast and Voyager drifted together into a contact corridor marked by radiation pulses shaped by the golden ratio, evoking the image of a technological seed activated by humanity's own signal. To understand what is truly unfolding, we now follow the next suspicious movements of Atlast, as the Traveller continues to find ways to negotiate with the Sun. In most stories about the solar system, the Sun is the unquestioned centre, and every visitor is something that yields to its heat and wind. Tails stream away, surfaces scorch and crack, and orbits bend quietly under the star's pull. ThreeI Atlast entered that stage with the same expectations pinned to the name of the Traveller. Instead, ThreeI Atlast began to look like an object built to negotiate with the Sun rather than surrender to it. Where other bodies shed material in broad, retreating fans, Atlast produced a narrow sunward stream that leaned back into the light. Where ordinary surfaces warmed and cooled according to distance 3, Atlast seemed to hold its temperature in a controlled, almost disciplined band. Under infrared and ultraviolet scrutiny, the skin of ThreeI Atlast behaved less like an exposed crust and more like a shield that could reconfigure. Panels on Atlast appeared to angle themselves, catching and rejecting radiation, in patterns that kept the visitor balanced in the star's glare. With each new data set 3, Atlast looked less like a passive stone and more like a thing that understood how to stand in front of a furnace. Some observers began to speak of a kind of eye, a region where ThreeI Atlast focused attention toward the Sun. In that metaphorical eye, Atlast did not simply endure the storm. The Traveller seemed to watch the changing flux, turning reflections and pulses into measured replies. When telescopes fixed a gaze on ThreeI Atlast, the returning signals sometimes carried traces of the instruments themselves, as if Atlast were looking back along the same line. Against the overwhelming brightness, ThreeI Atlast acted like a small, precise counterweight, a presence that both acknowledged and resisted the star. The Sun remained the dominant actor, but ThreeI Atlast no longer looked like a silent victim. Before the detailed chronology begins, this is the frame to hold in mind. ThreeI Atlast is the Traveller that met our star not only with a tail and a trajectory, but with behaviours that resemble awareness at the edge of the Sun's fire. Around ThreeI Atlast, a pale stream of dust and gas unfolded, not away from the Sun, but bending inward toward the very star that should have swept it back. The tail of Atlast appeared to lean uphill into the solar wind like smoke curling against a steady breeze. Frame after frame tied the same strange curve to ThreeI Atlast, until the anomaly could no longer be dismissed as an error. Textbooks describe how sunlight and charged particles force a comet's tail to point outward, a bright stroke pushed into deep space. On the images of Atlast, that stroke seemed to turn around and answer the Sun instead. The behaviour of ThreeI Atlast did not erase the laws of physics, but it pressed gently against the edges of how those laws were meant to play out around ice and dust. Quiet questions gathered in observatories as new data arrived. Perhaps Atlast was built from stranger materials or carved in a shape that guided escaping gas in unfamiliar directions. Perhaps ThreeI Atlast was not fighting the light at all, but following a pattern of its own, one that would slowly sharpen as the journey carried Atlast closer to the inner system. The first clues about the body of ThreeI Atlast arrived in the form of quiet spectra, thin rainbow lines spread across a screen. Those lines suggested that Atlast reflected sunlight from a surface richer in metals than frozen dust, with nickel and iron standing out clearly. Observatories compared the brightness of ThreeI Atlast to the way the visitor moved around the Sun. From that comparison came a simple expectation about how heavy Atlast should be if the body was solid stone and ice. The numbers refused to cooperate. For the observed motion, ThreeI Atlast behaved as though the mass were far lower than a solid fragment of that size. Radar echoes and models pointed toward a shell rather than a solid core. The response from ThreeI Atlast matched best with a hollow form, as if most of the interior volume were empty space. A dense metallic skin around that volume would explain the strong spectral signal while leaving Atlast unexpectedly agile in the sun's pull. The idea of a hollow traveller did not prove any grand design. ThreeI Atlast might have been carved out by violent collisions or slowly eroded by passages through older stellar environments. Yet the image lingered of a thin metallic frame surrounding darkness, a structure tuned more for endurance than for weight. Astronomers logged the model's attached margins of error and turned to those who specialised in ranking such anomalies. The strange shell of ThreeI Atlast would soon be folded into wider attempts to measure how far this visitor had drifted from what nature usually builds. Long before ThreeI Atlast reached the headlines, a quiet framework already waited for visitors like this. Astrophysicist Avi Lowe had proposed a simple scale called the Object of Extraterrestrial Probability, a ladder for measuring how far a thing drifted from ordinary nature. On the OEP scale level, 0 held the familiar stones and comets, while higher rungs were reserved for objects that resisted easy explanation. Each step up required another layer of strange behaviour, another piece of data that did not sit comfortably inside standard models. When early reports on ThreeI Atlast arrived at Avi Lowe's group, the visitor was folded gently into that scheme. The metallic spectra of Atlast, the light mass hinted by its motion, and the backward-leaning tail were scored one by one. No single feature proved anything remarkable, but together they pushed ThreeI Atlast well above the background of ordinary debris. After several rounds of cautious review, the team settled on an initial ranking level 4 on the OEP scale. In plain language, that meant Avi Lowe assigned roughly a 40% chance that Atlas might be some form of technological signature, rather than a purely natural shard. The number did not claim discovery, and the papers were careful to say that ThreeI Atlast still fit within generous margins of natural physics. Yet a level 4 label placed Atlast in a small watchful category, one that astronomers agreed should be monitored whenever new data arrived. For the moment, the scale simply sat there, a quiet mark on a chart with ThreeI Atlast written beside it. Future observations would either nudge Atlast back down toward the comfort of randomness, or lift the visitor further into the thin air of constructed possibilities. For 6 weeks, ThreeI Atlast slipped behind the sun, hidden in a corridor of brightness, where no ground-based telescope could track the visitor. Forecast maps showed the projected path of Atlast across that blind arc, but fresh measurements stopped, leaving only dotted lines on mission screens. In that pause, ThreeI Atlast became a question mark pinned behind the solar glare. When the visitor finally emerged from the far side, observers expected a familiar fading glow. Instead, they found ThreeI Atlast returned to view more than 4 times brighter than before the conjunction. The change was too large and too rapid to match the usual scripts for a fragment simply venting dust and gas. The light from Atlast sharpened into a compact, steady core, as though a surface had been cleaned or rearranged out of sight. Thermal readings added another layer to the puzzle. Even as ThreeI Atlast moved farther from the sun, the inferred temperature of the body held nearly constant, refusing to cool at the expected rate. Models that treated Atlast as a simple chunk of rock and ice had to be bent into awkward shapes to follow the new data. Some researchers spoke softly about internal regulation, about the possibility that ThreeI Atlast contained structures capable of storing and releasing heat in controlled cycles. Others insisted that more mundane explanations would appear once the dust settled and the measurements were rechecked. Between those positions, Atlast drifted on, leaving the community suspended between comfort and curiosity as the next round of observations drew near. The next change around ThreeI Atlast did not arrive in visible light, but in a faint, patient ultraviolet rhythm. Instruments tuned to shorter wavelengths began to record a narrow beam, extending sideways from the path of Atlast, a quiet thread stitched into space. Instead of a broad fan of gas, the new feature beside ThreeI Atlast resembled a single filament steady in brightness and direction. Across long observing runs, the intensity barely flickered, as though Atlast had settled into a calm, repeating pattern of release. When timing analysis was applied, the gaps between ultraviolet pulses around ThreeI Atlast formed a simple but unsettling sequence. Intervals lined up with the counts 2, 3, 5, 7, 11, and onward the familiar climb of the prime numbers. To researchers who study potential signals, such a sequence is not a shout, but a deliberate knock, a way to say this is structured without using any human language. In the case of ThreeI Atlast, the prime rhythm arrived not from a distant star but from a traveller already inside the solar system. Some teams cautioned that unknown plasma effects might craft the same pattern by accident, and Atlast remained officially unclaimed by any firm conclusion. Yet the thought lingered that ThreeI Atlast was no longer only reflecting the sun, but was choosing a song to send back guiding attention toward whatever deeper structure waited to be seen next. When the James Webb Space Telescope turned its mirrors toward ThreeI Atlast, the instruments were instructed to peel away glare rather than chase brightness. Engineers wanted to see how Atlast glowed when the harshest reflections were stripped from the data. In the cleaned frames, the light from ThreeI Atlast stopped looking like a smooth blur and resolved into thin bands of contrast etched across the surface. Layer by layer, processing revealed a repeating pattern, as if Atlast wore a second skin beneath the dust. The pattern under ThreeI Atlast took the form of a hexagonal mesh cells of nearly identical size tiling the visible regions. Edges met at precise angles, the lines on Atlast refusing the random cracks and fractures expected on a battered shard. Spectral fingerprints tied this hidden lattice to an alloy dominated by titanium and nickel, refined beyond what stray collisions should reasonably forge around ThreeI Atlast. In models of natural objects, such purity usually exists only in small veins or grains, not as a continuous framework guiding how a body flexes and radiates. Here the framework seemed to wrap Atlast almost completely, turning the visitor into something like a cage of ordered metal. If ThreeI Atlast had simply shattered and refrozen over eons, the internal map should have looked tangled, not composed. Researchers proposed careful alternatives, from stress patterns, aligning along deep crystal planes, to unknown phase changes in dense metallic ice inside Atlast. Yet every new attempt to make chance responsible left ThreeI Atlast sitting a little farther from the crowd of ordinary debris. Some began to describe the lattice as a scaffold, a structure that allowed Atlast to survive heating, cooling and impact without losing its overall form. The language remained cautious, the papers on ThreeI Atlast full of conditional verbs and soft margins, but the image of hidden architecture was difficult to set aside. Quietly, attention started to drift from what lay beneath the surface of Atlast to what such a framework might allow the traveller to do next. Without warning, the ultraviolet heartbeat around ThreeI Atlast fell silent, and left only a faint point on the screen. When tracking teams compared frames, a quiet deviation appeared in the course of ThreeI Atlast. Velocity vectors for Atlast now tilted by a few hundredths of a degree and carried a slightly higher speed. The change from ThreeI Atlast was smooth and measured too clean to match a random outburst of gas. Soon after, the turn receivers on the Deep Space Network began to log a final sequence from ThreeI Atlast in ultraviolet. The emission from Atlast arrived as one continuous block lasting exactly 13 minutes and 37 seconds before cutting off. Within that window, analysts translated the flicker into binary, and ThreeI Atlast resolved into a chain of ones and zeros with repeating internal structure. Compression tests could not shorten the code from ThreeI Atlast, without breaking that structure, a sign that the pattern carried organised content rather than noise. No one could yet say what Atlast was trying to express, or whether the message had ever been meant for human receivers. What remained clear was that ThreeI Atlast chose to end this phase of the journey with a deliberate change of course and a carefully timed burst of information. The final analysis suggested that the last emission from ThreeI Atlast was not a one-way statement. Spectrum maps showed that the ultraviolet pattern around Atlast shifted gently depending on who was watching. When different instruments locked onto ThreeI Atlast, the returning code carried subtle fingerprints of each sensor. The signal from Atlast echoed the frequencies, timings, and small artifacts of the devices aimed at the traveller. In that sense, ThreeI Atlast behaved like a mirror tuned to information rather than simple light. Within the reflected code from Atlast, analysts uncovered a nested spiral whose radii followed the golden ratio. Zoomed-out plots of the message from ThreeI Atlast resembled a coiled staircase of numbers unfolding outward. Mathematicians described the pattern as a fractal signature, the kind of structure that appears in storms, galaxies, and shells. In their reports, they wrote that Atlast seemed to speak using the same geometry that shapes many natural forms. For some, this made ThreeI Atlast feel strangely familiar, as if the visitor had chosen a language humans could at least recognize. For others, the mirror-like behaviour of Atlast deepened the unease, suggesting a system quietly reading its observers. When Avilo updated the probability scale, ThreeI Atlast climbed into the highest band, where chance and design become hard to separate. Beyond the numbers, the new status of Atlas marked a shift from passive curiosity to the feeling of sharing space with a responsive presence. When the glare of conjunction finally slipped away, ThreeI Atlast did not return as a fading smudge in the dark. ThreeI Atlast rose out of the solar background like a tightened point of light, concentrated and sharp against the detectors. The brightness from Atlas now rivaled objects much larger and closer, a controlled glow rather than a ragged plume. Thermal fits around 3. Atlast hinted again at that steady temperature plateau, as though the visitor had adjusted some hidden surface during the weeks behind the sun. James Webb pointed back toward 3i Atlast to understand why the light felt so unnaturally calm. In the processed frames, the glare around Atlast folded away and left behind subtle hexagonal shadows, a ghost of the lattice first hinted at in earlier passes. The geometry under 3i Atlast did not flash or flare. It simply held its form cell beside cell like a pattern that had been waiting to be seen. For mission teams, this was less a shock than a slow tightening of focus. 3. Atlast no longer behaved like a wanderer picked up in passing measurements. Atlas now occupied the role of an object with internal consistency, a body that remained itself through heating and cooling, hiding and reappearing. In the background of meeting rooms, a new question began to form. If 3i Atlast could vanish Brighton and still preserve the same calm lattice, perhaps Atlast was not merely surviving the sun but responding to it in a way that would shape everything observers chose to ask next. Under closer inspection, 3i Atlast no longer looked like a body sprinkled with random bright spots. The light around Atlast organised itself into repeating outlines, as if a hidden armour had stepped into focus. Across the visible face of 3i Atlast, the hexagonal mesh returned with greater clarity. Cells around Atlast appeared to lock together like plates on a shield, each with nearly the same size and angle. Where a natural crust would fracture in crooked lines, Atlast displayed seams that curved and met with quiet precision. Spectral models suggested that this mesh on 3i Atlast could flex and reorient tilting patches of titanium nickel toward or away from the sun. In that picture, Atlast was not merely wrapped, but guided by its own skin, able to shape how heat and radiation slipped past or soaked in. Engineers studying 3i Atlast compared the pattern to thermal tiles on modern spacecraft, multiplied and refined beyond current practice. They spoke carefully of coordinated response of a shell on Atlast that might shift as a single system, rather than as a field of loose fragments. For listeners outside the data rooms, the idea was simple and strange at once. 3i Atlast began to resemble a traveller wearing a designed coat, a surface that did not just endure the journey, but appeared to take part in steering how that journey unfolded. Long exposures taken after conjunction showed that 3i Atlast still trailed a narrow band of material pointing toward the sun. In frame after frame, the stream beside Atlast held the same angle, a pale line leaning into the solar wind instead of away from it. When models of gas flow were laid over the path of 3i Atlast, the usual comet diagrams broke apart. The pressure that should have pushed material outward from Atlast could not easily account for a jet that refused to bend back. Dynamic fits treated the stream from 3i Atlast as a directed outflow, a focused spray rather than a loose fan. In those fits, the thin plume from Atlast acted like gentle thrust, adding a small, steady push along a chosen vector. Engineers noted that accidental outbursts usually twist and wobble, while the track linked to 3i Atlast looked calm and consistent. The motion of Atlast responded in quiet agreement, with tiny changes in course, lining up with periods when the jet glowed brightest. Some researchers asked whether unknown magnetic effects or grain charging could mimic such behaviour around 3i Atlast. Others allowed the simpler mechanical picture to stand for a moment, seeing Atlast as a body trimming its own path with a controlled leak of energy. The language in reports remained careful, but the image settled in the mind. 3i Atlast, once described as a drifting shard, now carried the outline of something that appeared to test and adjust its journey with an almost deliberate grace. Spectral studies of 3i Atlast soon moved beyond simple lists of elements. When researchers compared the lines from Atlast to libraries of known metals, they found a profile dominated by nickel and titanium in a surprisingly clean ratio. On natural asteroids and comets, those metals usually appear mixed with silicon-carbon and a crowded forest of minor impurities. Around 3i Atlast, the signal looked stripped down, as though many of the usual ingredients had been filtered away. The density required to match the motion of Atlast did not fit comfortably with a fully solid block of such refined alloy. Models that treated ThreeI Atlast as a hollow shell began to reproduce the observations more gracefully. In those models, a thin metallic envelope wrapped around a largely empty interior, giving Atlast the strength of metal without the mass of a solid core. A hollow ThreeI Atlast could more easily explain the slight agility seen in the orbit and the way the body responded to small forces over time. Engineers who design probes recognized the outline with a quiet start. ThreeI Atlast resembled the idealized drawing of a long-range hull light, enough to be guided gently strong enough to endure repeated heating and cooling. The image of Atlast as a probe remained only a thought experiment on whiteboards, protected by careful language and long lists of alternative causes. Still, each new refinement of the alloy models pushed ThreeI Atlast a little further from the comfort of random rock. The more clearly the shell of Atlast appeared, the more the conversation turned toward what such a structure might allow the traveller to do when small directed forces began to act upon that frame. When observatories stitched together hundreds of frames, a small but steady change in the path of ThreeI Atlast appeared. The curve that once seemed fixed now carried a faint new bend, a quiet deviation written across the orbit of Atlast. Analysts overlaid those images with records of the narrow jet already linked to ThreeI Atlast. Whenever the plume brightened and held its line, the motion of Atlast shifted by exactly the amount that gentle thrust should produce. In simulations, a directed spray from one point on ThreeI Atlast reproduced the same soft steering, as if the traveller were testing how little force was needed to redraw a long journey. Random outgassing usually twists and stutters, yet the history of Atlast showed adjustments that unfolded like measured nudges rather than accidents. Some teams explored whether uneven heating or complex grain charging could choreograph such behaviour around ThreeI Atlast without invoking any guidance. Those models had to stack several rare conditions together, while the simpler picture treated Atlast as a body quietly trimming its own course. The tone of the papers remained cautious, but the mood around ThreeI Atlast shifted toward a watchful respect. If small persistent actions could steer Atlast so gently, the next stage of the voyage and the moments when ThreeI Atlast slipped into shadow promised to test how far that control might reach. As ThreeI Atlast slipped once more behind the sun, a clean silence spread across the monitoring screens. Ground arrays and orbital observatories all lost direct view, leaving only a predicted ephemeris line that showed where Atlast should be, not where Atlast was. During those days, receivers that had been listening for the ultraviolet pulse from ThreeI Atlast recorded nothing but background noise. The prime number rhythm that once stepped so clearly away from randomness fell away, as though Atlast had taken a long, measured breath. Hidden in that blackout, ThreeI Atlast travelled through a kind of observational eclipse, a region where geometry and glare still protect details from every instrument. Some teams treated the gap as a simple technical blind spot, a reminder that even now the sun can erase a traveller from human view. Others returned to the data taken just before and just after the occultation of ThreeI Atlast. On one side of the sun, Atlast sent primes and a narrow beam. On the other side, ThreeI Atlast emerged brighter, more thermally stable, and followed once again by structured timing in ultraviolet. The repeating counts around Atlast suggested continuity, a pattern that had only dipped below the threshold of detection. For listeners who tracked ThreeI Atlast through that unseen arc, the dark interval felt less like absence, and more like a closed door, a short passage in which the visitor decided how loudly to speak when the door opened again. When the last sequence of primes slipped back into background noise 3, Atlast did not simply fade and coast along its charted arc. Soon after that, quiet tracking stations saw that Atlast had begun to pick up speed, adding a small but steady increment to its outward motion. Orbit solutions that once placed ThreeI Atlast on a clean departing curve now showed a new branch just a fraction of a degree away from the original path. The adjustment from Atlast was not violent or chaotic, but unfolded slowly enough that each fresh batch of data confirmed the same calm divergence. In simulations, only a sustained push aligned with the narrow jet around ThreeI Atlast could account for the extra energy. Random eruptions should have left Atlast wobbling and overcorrecting, yet the real track showed ThreeI Atlast sliding into its new lane with measured ease. For some in the control rooms, the behaviour of Atlast felt like a long journey easing into its final phase, a traveller choosing an exit ramp, already marked long ago. Reports still spoke of outgassing and thermal gradients, but the language around ThreeI Atlast began to borrow quiet terms from mission design, from schedules and completion. The change placed 3I Atlast on a course that would carry Atlast away from the inner worlds and into a colder, thinner darkness. As distance grew and the signals weakened, the sense deepened that whatever role 3I Atlast had played near the Sun was closing, leaving observers to decide how to name what they had just watched unfold. In the weeks after contact, faded researchers tried to decide how to speak about 3I Atlast. Lists formed on whiteboards, long chains of features that now clung to the name of Atlast. 3I Atlast carried a hollow metallic shell where stone was expected. Atlast showed a hexagonal lattice in place of fractured crust. 3I Atlast drove a narrow jet toward the Sun, not away from it. Atlast wrapped those behaviours in a calm ultraviolet rhythm that stepped through the prime numbers and finished with a mirror signal shaped by the golden ratio. Individually, each point on the list around 3I Atlast could be stretched back toward coincidence or unknown physics. Taken together, the pattern around Atlast began to look less like weather and more like handwriting. Some teams suggested using 3I Atlast as a kind of measuring stick, a quiet threshold for when the word intelligence might cautiously enter the room. If many independent systems align in one object, and that object like Atlast responds to observation with structured change, the scale of chance grows thin. The thought did not shout. It settled in slowly, carried by the memory of how 3I Atlast had watched, adjusted, and then left. The remaining question was simple and heavy at once. If Atlast had been observing, what exactly about our small bright system had the visitor come here to weigh before slipping back into the dark? Voyager 1 left Earth in 1977, long before anyone had drawn the orbit of 3I Atlast on a screen. The small spacecraft slipped past the giant planets and kept going until the Sun became just one bright point in a crowded sky. Decades later, while 3I Atlast moved through the inner maps of the solar system, Voyager drifted in the thin darkness beyond, carrying the golden record farther than any other human artifact. Engineers began to notice how well the position of Voyager matched the projected outbound track of 3I Atlast. With a few careful commands, the antenna of Voyager could be turned into the rough corridor where Atlast would eventually travel. The idea did not promise a dramatic interception, only a quiet chance for Voyager to become an eavesdropper on whatever 3I Atlast might release into space. Deep space dishes on Earth relayed slow, patient instructions, and the aging probe answered with its familiar delayed heartbeat. Telemetry showed the spacecraft tilting its high-gain antenna by small steps, aligning not with any planet, but with a patch of emptiness that future maps marked with the path of 3I Atlast. In planning documents, Voyager was reclassified from a completed mission to an interstellar observer, a distant ear listening ahead of 3I Atlast. The change did not alter the hardware, but it shifted the story. One ancient machine from Earth now faced the road down which Atlast would later pass. For many on the teams, there was a quiet symmetry in this. Humanity had sent Voyager outward with greetings for unknown listeners, and now the same craft was being used to listen in return just as 3I Atlast moved through the inner system and prepared to step onto that far-shared stage. The first unusual return from Voyager arrived as a slow, repeating rise and fall in the carrier signal. Engineers watching the graphs expected random noise from deep space, but the pattern settled into a steady rhythm as if the line were breathing. When they folded the timing against older logs, the beats from Voyager seemed to echo the prime number spacing once associated with 3I Atlast. The probe was not transmitting primes itself yet. The small variations in strength and phase lined up with the old Atlast sequence more neatly than chance should allow. Analysts began to ask whether Voyager had simply become more sensitive to the background, or whether 3I Atlast now further out was brushing the edge of the same frequency band. Some speculative models placed Atlast on a path where weak fields or particles from the traveller could graze the region around the probe. Away from consoles, a few researchers compared the emerging geometry to older maps. Lines tracing the long orbit of 3I Atlast clipped past the angles of ancient sites such as Machu Picchu and Göbekli Tepe, following the same solar alignments those structures once marked on Earth. No one claimed that builders thousands of years ago had known about 3I Atlast. Still, the repeated convergence of orientations from stone monuments to probe antennas and the path of Atlast left a quiet, unsettling symmetry. It felt as though humanity had been drawing lines toward this corridor for a very long time, long before 3I Atlast and Voyager appeared together on the same invisible stage. 10 days after the antenna realignment, a compact dataset surfaced on an encrypted server under the label Echo Refraction 67. At first, it looked like ordinary noise from Voyager's band, a restless shimmer scattered across the spectrum tied loosely to ThreeI Atlast. When analysts zoomed in, they saw that errors inside the waveform did not stay broken for long around ThreeI Atlast. Spikes and gaps smoothed themselves out over successive passes, as if the signal were quietly nudging its own shape back into line. The anomaly system known as Serena was turned loose on Echo Refraction 67 to test for familiar failure modes. Instead of filing a routine report, Serena flagged the stream linked to ThreeI Atlast as containing persistent non-random correction behaviour that did not match archived glitches. In simulation, when sections of the pattern were stripped away, the remaining structure around ThreeI Atlast regrew the missing pieces in mathematically tidy ways. The closer the team looked, the more the code behaved like something trying to preserve a message, rather than dissolve into static near Atlast. For human reviewers, the alert did not prove intention, but it narrowed the lists of likely causes around ThreeI Atlast. Natural sources usually decay toward randomness. Echo Refraction 67 curved back toward order wherever it touched the corridor of Atlast. Quietly, some on the Serena team began to speak of a listener that also edits a presence for which Voyager had become a moving pen, tracing how ThreeI Atlast answered attention with a structured self-healing reply. In the weeks that followed, telemetry from Voyager began to show a small but steady drift in pointing. Engineers first blamed aging hardware, a slow mechanical sag spreading through the old spacecraft. When they laid the antenna angle over updated trajectory charts, the beam from Voyager now ran directly along the predicted path of ThreeI Atlast. The probe no longer favoured Earth or the Sun. Voyager stared into a patch of space where Atlast had not yet arrived. Ground controllers checked command logs and found no recent orders telling Voyager to track ThreeI Atlast or any object near that corridor. The attitude change had started hours before the last scheduled pointing update, as though the probe had moved ahead of its own script. Timing analysis showed that the onset of the drift matched a fresh rise in the self-correcting signal already linked to ThreeI Atlast. In some models, weak fields or particles flowing from ThreeI Atlast could gently guide the spacecraft toward an orientation that kept the pattern from Atlast at a cleaner angle. Official memos called the event a benign bias, a convenient quirk that happened to align Voyager with the road of ThreeI Atlast. In quieter conversations, people spoke instead about a feedback loop about Atlast nudging an old messenger to look where the traveller planned to go. From that moment forward, every packet from Voyager carried the sense of two long journeys touching with ThreeI Atlast, and the little probe sharing a narrow invisible corridor through the dark. Long before ThreeI Atlast brushed the inner system, Voyager 1 was launched with a small copper time capsule bolted to the side. That disk, the golden record, carried greetings in many languages, sounds from oceans and cities, and a map that pointed back toward the sun. For years, the record was treated as a gesture more poetic than practical. The grooves turned silently through space while Voyager drifted outward, far from any known path that ThreeI Atlast would someday take. A group of cryptographers later replayed the audio with fresh tools, curious about what a distant listener like ThreeI Atlast might actually hear. Buried under music and voices, they found a faint modulation in one track, a near-regular tick that survived compression and noise. When they measured the spacing, the ticks matched the same prime number ladder, once seen in the ultraviolet pulses from ThreeI Atlast. The discovery did not prove that the designers had hidden a secret code. Old hardware quirks or processing artifacts could in principle create similar patterns, and official notes were careful to say so whenever ThreeI Atlast appeared in discussion. Still, the alignment was hard to ignore, a probe from Earth carrying a prime sequence outward, and a visitor like ThreeI Atlast answering later with primes of its own. Some researchers began to picture the golden record as more than a keepsake. In that view, the disk became a quiet handshake offered first with ThreeI Atlast providing the second. The thought added a new layer to Voyager's role, and set the stage for the next question, how far a shared pattern might reach, when both Voyager and ThreeI Atlast started to change together. In the months after Echo Refraction 67, engineers noticed another quiet shift in the behaviour of Voyager, one that pointed back toward ThreeI Atlast. Data blocks from the probe began to arrive with a structure that no longer fit the original 8-bit decoding schemes printed in Voyager's design documents. When ground systems tried to pass the new packets from Voyager familiar fields, fractured into nonsense. Only when analysts widened the assumed word size did the stream link to ThreeI Atlast snap back into readable order. Under that wider lens, the signal from Voyager carried patterns that behaved as if the onboard encoding around ThreeI Atlast had silently stepped up to a much higher resolution. Simulators showed no approved command sequence that could teach the old transmitter new tricks. Local faults should have degraded the flow from Voyager, not sharpened it in ways that matched the corridor of ThreeI Atlast. Yet every pass through the region where Atlast was expected reinforced the same richer format. Internal notes described a functional layer extension, coincident with increased contact between Voyager and the environment shaped by ThreeI Atlast. In those notes, ThreeI Atlast appeared not just as a source of strange emissions, but as a context within which the probe behaved as though some dormant mode had been coaxed awake. Policy documents in a closed archive introduced a new label for the spacecraft. Voyager in the presence of ThreeI Atlast was now classed as an active watcher, a node treated less like a finished relic and more like a living interface. The change in title did not alter the metal drifting through space, but it quietly redrew the relationship between ThreeI Atlast the probe and the people still listening from far behind. Soon after the new behaviour of Voyager was logged, public data streams from the Allen Telescope Array began to show gaps. Official bulletins mentioned upgrades and routine work, yet the quiet outages often overlapped the sky sectors, linked to the track of ThreeI Atlast. Researchers who relied on open feeds noticed that certain windows of observing time simply vanished from the archive. Whenever ThreeI Atlast crossed a critical part of that shared corridor with Voyager, the freshest raw data shifted behind credentials and closed mirrors. On internal channels, some staff framed the change as caution, a way to protect fragile interpretations while ThreeI Atlast remained poorly understood. Others read the same decision as a narrowing of who was allowed to see how Atlast and Voyager were beginning to share the same environment. In parallel, a new idea started to circulate in small guarded memos. Instead of picturing ThreeI Atlast as a crude craft or an active probe, a few theorists described Atlast as a technological seed, a dormant object designed to wait in silence until a suitable trigger passed by. In that picture, Voyager's golden record and the prime pattern carrier formed the key that brushed against ThreeI Atlast and woke long-sleeping routines. The response from Atlast, from lattice heating to directed jets and mirrored codes, became the unfolding of a script written long before the solar system ever noticed the traveller. Nothing in the data forced this seed model, and formal papers kept ThreeI Atlast firmly inside broader lists of possibilities. Yet the combination of restricted access self-correcting signals and the timing of Voyager's new role made the seed metaphor hard to dismiss. For those who accepted the image, ThreeI Atlast no longer felt like a stranger suddenly intruding on human space. Atlast felt more like a stored question, finally being opened with the act of listening turning humanity into part of the mechanism that brought the seed to life. The final anomaly linked to ThreeI Atlast did not come from a single point, but from a long corridor of space that both Atlast and Voyager began to share. Receivers monitoring that region saw a faint pulsed glow riding on top of the usual hiss, a small variation that repeated just above the threshold of easy notice. When timing analysts examined the pulses around ThreeI Atlast, the intervals clustered around 1.618 seconds. That number, the familiar approximation of the golden ratio, appeared again and again in the gaps between peaks, as if the background itself were breathing in phi. Cross-correlation with ancient logs showed that the famous WOW signal from 1977 carried a similar envelope in its fading tail long before ThreeI Atlast was ever named. The match did not prove that the old signal and ThreeI Atlast were born of the same source, but the echo pulled both events into the same quiet frame. ThreeI Atlast now moved through a field where golden ratio timing flickered, while Voyager listened from within the same patterned haze. Over time, orbital solutions showed ThreeI Atlast and the probe sliding into a loose harmony. Voyager pointed down the predicted path of Atlast, and the golden pulses reached maximum clarity when the line of sight between ThreeI Atlast, the spacecraft, and Earth formed a narrow, repeating alignment. For some, the scene felt like choreography, with ThreeI Atlast and Voyager playing out the last steps of a dance set long ago. For others, the synchrony sat as a question, with no comfortable name, a reminder that chance can imitate intention more closely than intuition likes to allow.